All right, let's start this class up, guys. Good morning. All right, I'm gonna go and assume we're not gonna have school tomorrow. All right, because of the big snowstorm coming in. So I'm going under that assumption. If I'm wrong, okay, we meet tomorrow, even if it's on time or it might be a delay. But I'm going under the assumption right now that we're not going to meet tomorrow because school's closed. So with that being said, I did not want to just email everybody, scramble to make sure you guys knew what was going on. I'm going to tell you what's going on right now. All right, so no school tomorrow. First, let's talk homework. Tonight's homework. You have 2 proofs out of the packet tonight for me, and then you have textbook questions to try. Make sure you do the textbook questions because those are basically a review for the quiz. All right, that homework will be due Friday, 10 a.m. All right, don't worry about what's on Thursday if we don't have school tomorrow. That homework's going to be due Friday, 10 a.m. The quiz will still be Friday. I am not going to push it to Monday. I don't think that's a good idea for some of you for me to push that off to Monday. All right, so the quiz is still going to be Friday, whether we meet or not tomorrow. With that being said, I am still going to be here tomorrow afternoon for a review. All right, I got no problem logging on and helping you guys out from 2:15 to 3. What else are we all going to be doing other than sitting home and watching the snow come down? All right, so I will still be here tomorrow, 2:15 to 3, for you guys to ask any review questions for the quiz. And then the rest is numbers 3 through 8 are all about the quiz. If we're not going to meet tomorrow, I wanted to get this information to you right now. There will be one question that requires factoring. I don't want to blindside you guys on Friday. You're going to set up an equation that's going to have an x squared in it, and you're going to have to factor it to solve it. If you want practice on that, I'll talk about that in a minute. One proof on there, I told you guys this yesterday during class, one proof, it'll be given a parallelogram and then prove something after. All right, so I will give you the figures of parallelogram. You got to do something with it. Up on Google Classroom under Unit 6, I've already put a folder of extra practice questions for you, ready to go. All right, so if you guys want extra practice to get ready for Friday, it's up on Unit 6 under Classroom. On Classroom under Unit 6. Okay, so I just wanted to push this out to you because it's probably a good chance that we're not going to meet tomorrow. Unless you're coming to review at 2:15, which I'll be available for. All right, so I just wanted to make sure we are clear on the expectations when we don't meet tomorrow. Homework will be due. Tonight's homework will be due on Friday at 10 a.m. 1 p.m. You guys are 1 p.m. It's 4th period now. 1 p.m.
Is there practice or factoring on?
That is one part of it. Yes. There's three sets of questions in that folder on Unit 6 on Classroom, and one of them is solving equations by factoring. The other 2 are parallelogram proofs and interior and exterior angles of polygons practice. Any other questions I can answer before we turn our attention to last night's homework? All right, so
will we get homework tomorrow?
Nope. Don't even worry about what's on the if we don't meet tomorrow, anything on the assignment sheet for Thursday will get pushed to next Monday. Okay? So if we do not meet because school's closed tomorrow, don't even worry about what's assigned for Thursday or what we're supposed to talk about. I'm going to push it to Monday. So that means when you guys log on Friday morning, make sure you got your camera set up, all ready to roll because you're taking the quiz. Okay? So make sure that's ready to roll. So quiz still on Friday no matter what happens tomorrow. I just didn't think it was a good idea for some of you for me to push it to Monday. And we've talked about everything already that's on the quiz. There's nothing new I'm going to talk about today. Any other questions before we go homework? Okay. I just got to switch screens to present. So give me 1 second. Let's get the homework ready. Okay. You guys had 5 proofs. Period 1 had a bunch of questions for me. So if you guys do, great. Because there's not a lot we need to do as a group today, right? There's not a lot in the notes we need to do. So if I take a lot of time going over homework, I am okay with that. Just got to pull up the notes and we'll be ready to go. Is there something you're going to want me to go over here as I pull all this stuff up? Any questions you want to go in more detail about? Any proofs you want to go in more detail? Because there were a couple tricky ones.
Number 5.
Yep, that last one. And some of you could have did it a different way than what I did on my answer key, but I'll go over the way I did it on my answer key. Quadrilaterals, flowcharts, 20, 20, Wednesday. Okay, let's present and we'll get rolling. All right, finally, here we go. Let's get to number 5 and let's talk. If 5 would come up. Yep. All right, here we go with number 5. Here's the way I went about it. We knew that this entire quadrilateral was a parallelogram. A, B, C, D, this whole thing was a parallelogram. So when I said, all right, here's how I started. If that's a parallelogram, I know opposite sides are congruent. So I said AD congruent to BC. I said AB congruent to DC. All right, because I know opposite sides are congruent. So that's how I started it out. Opposite sides are congruent, so I know those 2 pairs of sides are equal to each other. Then, and I didn't mention this yesterday, but I'll give you a little secret or a tip. Anytime you have a parallelogram that has at least 1 diagonal drawn in, if you have a parallelogram with at least 1 diagonal drawn in, chances are pretty high that in that problem, you're probably going to need the alternate interior angles. All right, there's a pair of alternate interior, and here's a pair of alternate interior. So anytime you're dealing with a parallelogram that has at least 1 diagonal drawn in, make sure you look for some alternate interior angles because they're there. They will always be there as long as it's a parallelogram. Why do I tell you this? Go back to my problem. Well, AB is also parallel to DC. So that makes this angle right here congruent to this one down here because they're alternate interior. All good so far. Also, AD is parallel to BC, which forms another pair of alternate interior angles right here and right here. So does everybody see the alternate interior angles I just got from diagonal AC? We're all good? Before I move on, please, because I always see this is a common mistake when kids do parallelogram proofs. Before you tell me those alternate interior angles are congruent, you need to tell me those sides are parallel. And then AB parallel to DC. Please tell me, before you tell me that, let's see, I'll just take one pair here. BAJ congruent to angle, let's see, what's that other one? KCD. All right, before you tell me the alternate interior angles are congruent, make sure you tell me the lines are parallel first. Parallel lines imply alternate interior angles. All right, a lot of people forget that step. Go ahead.
Why is finding the alternate interior angles necessary?
You want to? I'll keep going here, Maeve. You ready? This is just how I did it. Now, after I have the alternate interior and the sides congruent, what I did was the following. Let me mark this. I'm going to call this triangle 1 and triangle 2. Those two triangles are now congruent by side angle side for me. So that's why I needed the angles. So I could prove those two triangles side angle side. So I could say CPCTC, BK, and JD are equal by CPCTC. So I did side angle side to get those two triangles congruent. That's why I needed those alternate interior angles. Then I said, look at the two triangles on the top and the bottom. Let me call this triangle 3 is now congruent to triangle 4, also by side angle side. And if I didn't have those alternate interior angles, I couldn't use side angle side. CPCTC, now you have DK congruent to JB. CPCTC. And now that inside figure is a parallelogram because opposite sides are congruent. That's how I proved both pairs of triangles. So triangle 1 congruent to triangle 2 and triangle 3 congruent to triangle 4. And I know I should be naming them with the letters, but this is a little quicker, by side angle side. And if I didn't put the alternate interior angles in there, there's no way I could have proved them by side angle side. Okay, so that's how I went about number 5. Are there other ways? Maybe. Once I find a way, I don't look, just like you guys, I don't look for other ways. Other comments on 5 or other numbers that we want to just take a look at?
On number 3.
Yep.
I noticed when I was looking at the answers that one of the steps was having to say that they bisect each other.
Correct.
Which you normally say that before going on to say diagonals bisect each other.
Correct.
Equals parallelism.
Yep. I wanted to talk about this specifically, so thank you for bringing it up. It said LM and MJ were equal, and then it said LM is a median. So you guys had to know from last unit what a median was. Medians go to midpoints. It bisects the side it's drawn to. So KM was congruent to MG by definition of a median. Now, Sophia is absolutely correct. And I'm going to go over another proof just like this today. Is if you're going to tell me this is a parallelogram, all right, so your last step, I don't know what it was, I'll just say step 6, is GJKL is a parallelogram. And your reason's going to be diagonals bisect each other, imply a parallelogram. Well, you have to tell me the diagonals bisect each other. Just showing me LM equals MJ and KM equals MG, that you're not telling me they bisect each other. You need an actual statement up here that says, hey, KG and LJ bisect each other. Actually write down that the diagonals bisect each other. And your reason can simply be show both pieces are equal to each other. Show LM. I already have LM congruent to MJ. And I have KM congruent to MG. Okay, so yes, if you are going to use that as a reason, a finishing reason to say it's a parallelogram, you do need to say somewhere in your proof that they do bisect each other and why. Just having the 4 little pieces equal is not good enough. That's not enough to say they bisect each other or that it's a parallelogram. Others that you want to talk about?
4.
Okay, what was up with 4?
I just didn't understand it. I don't know.
Okay, so first thing, you had they gave you ABCD was the parallelogram, right? ABCD is a parallelogram, and I'm looking for ABEF also to be a parallelogram. So the first thing right off the bat, I see that I'm taking DC and just moving it out to F. Wait a second. Wasn't DC parallel to, rewrite that. Wasn't DC parallel to AB? Because opposite sides of a parallelogram are parallel. Now, all I'm doing is taking DC and making it a little longer. So shouldn't FE be parallel to AB as well? Because both DC and FE are on the same line segment. That's what we called extensions of parallel lines or parallel yesterday. Okay, extensions of parallel lines. So that's how I got DC to be parallel to AB. Now, a couple different ways right now. Let me just go the traditional way before I show you the shortcut. We were given perpendicular lines, so you guys should have had a right angle here and a right angle here in your diagram. You guys know right angles are congruent. Because the right angles are congruent, do you see how on FA and EB, those right angles are also corresponding? All right, so after you said the right angles were congruent, you could have said, oh, now FA is parallel to EB because congruent corresponding angles imply parallel lines. So that's how you could have gotten the other set of lines to be parallel. The traditional way. Does everyone see that? That the right angles you have on your diagram are also corresponding. So that makes those lines parallel. The quicker way to get those lines parallel, and you would have had to dig real deep for this theorem, is go back to the givens. What do you notice about BE and AF in the givens? They're both perpendicular to the same line, FC. And we had a theorem that said two lines perpendicular to the same line are parallel to each other. All right. And again, that's just one way. That's just one way. People sent me proofs last night that had these congruent because they proved the triangle's congruent on the outside, and these parallel because they use corresponding angles. Okay, fine. That's great. There's different ways to do it. I chose to do opposite sides are parallel. Some other people tried to do one pair of opposite sides congruent and parallel. So there are ways around it. Okay, Maeve, you all right here? Sure? Okay.
Do you think we should go over, or should know them for the quiz, those three theorems that we did, in one day?
They're not. Here's the thing, Sophia. Those three theorems are just shortcuts. They will never, ever be 100% required. Because did you see, I didn't need this two lines perpendicular to the same line theorem. I could have just did corresponding angles. So there's always going to be another way to do it other than using the theorem only. Okay, I just think those theorems I gave you are just shortcuts. That's it.
How would you use corresponding angles?
What do you mean, how would I use it?
How would you use it for the diagram?
Okay, so in this one right here, first thing I have to say is angle F and angle CEB are right angles. Perpendicular lines form right angles. Next step, I tell you they're congruent. All right angles are congruent. Then you could tell me FA is parallel to EB. Corresponding angles congruent imply parallel lines. Because those right angles, where they are in the diagram, are corresponding to each other. Because you have FA and EB as your parallel lines. And then if you draw in transversal FDEC right here, do you see if I take those four angles, move them down, the right angles would match right on top of each other. So that's why I can call them corresponding. Great questions here, guys. Great questions. Everyone all right now? We okay? Not doing anything different. We're doing 2 more proofs today where you're still in the proof statement going to prove to me that a quadrilateral is a parallelogram. But yes, since it is day 2, it's going to be a little tougher. All right, if you have a chance right now, go ahead and submit your homework. If not, you guys know the deal. 1 o'clock, and then get ready for our first proof here today. I got the numbers ready to go. I am also going to get on your laptops to make sure we're doing the right thing. And I know you guys will love to hear this. The software I use to take a peek in on your laptops has just come out with, I can send custom messages to everybody. So instead of saying, why are you on your textbook in front of the whole class, I can write you a more private, detailed message. Like, get your act together and get in the meat. I know you guys are happy to hear that, some of you guys. And some of you guys have no idea what I'm talking about because you guys follow the rules. Whew. Okay, today, be prepared. Today, you guys are going to, I don't want to say teach the class, but you guys are basically going to make the class go today. All right. You guys are going to build these proofs together, and all I'm going to do is insert my comments on maybe you want to think about this, maybe you want to do this a little bit differently, but you guys are going to really drive the class today. All right, so let's take a look at the first example here. Let's roll. It's a two-part question. Go ahead and mark your diagram because I gave you a ton of givens here, I got FG congruent to EG. I got AG congruent to GC. And I also gave you angle B and D congruent. All right. Ready for part A? We're going to help each other out. You guys drive the class. Part A, prove to me that BC and DA are equal. BC and DA are equal. Correct my mistake right now. I'm going to call on somebody to correct my mistake. What I want to do in step 2 is to say BC is equal to DA, opposite sides are congruent. Why am I wrong? All right, let me say that again. I want to go step 2, BC is congruent to DA already because opposite sides are congruent. Why am I wrong?
You haven't.
Whoa, settle down. 24, here we go. Emily, do you know why I'm wrong?
Yeah, because you didn't prove that ABCD is a parallelogram.
Good job, Em. Good job. Guys, that's a parallelogram property. In the givens, it's only a quadrilateral. I tried stressing this yesterday to you. Quadrilateral has 4 sides. That's it. Okay? That's it. So this is not going to be a 2-step proof. All right. So how can I get BC congruent to DA? I don't know. We've done proofs for, what are we on here? December, September, October, November, 4 months now. Anytime I needed to get 2 sides congruent, usually we prove triangles congruent so we could throw a little CP/CTC at it, right? So I think that's the way we got to go about this. To get BC congruent to DA, can we prove a pair of triangles congruent? Name them. Name 2 triangles that if they were congruent, we could get BC and DA equal. Name the 2 triangles. 22, here we go. Hannah, do you see 2 triangles I could try to prove congruent?
Triangle FGC and triangle AGE.
FG, well, hold on. Here's the problem with those 2. They don't have BC as a side or AD as a full side.
Well, can we use them to get this?
Well, we'll get there, Hannah. We'll get there. I'm just looking for right now, Hannah. Name 2 triangles that have BC and DA as full sides.
Triangle BAC and triangle ACD.
You got it. So that's where I want to start right now. Here, these 2 right on top of each other, guys, are what we are going to try to prove congruent together. All right, you guys take it from here now. What do I know in those two triangles? What do I already have congruent? What do you already have congruent in those two triangles? Here we go. 5. Hayden, what do I already have congruent in those two triangles?
CA.
Okay, so Hayden's going to go, hey, I see AC in common. So AC congruent to itself. Let's get that down. And that gives me a pair of sides. Was there anything in the givens in those two triangles? Anything in the givens that's already congruent? Let's go 4. Gideon, anything in the givens that are also in those two triangles?
B is equal to D.
All right, so up in the givens, I can put a little A in parentheses. So I have a pair of angles. I have a pair of sides. One more pair, we're good. One more pair, we're good. Whew, all right, take a peek. Anybody see any other sides or angles that you can prove congruent in those two triangles? Don't tell me 3 and 4 because they're alternate interior. It's not a parallelogram. Sorry. Don't give me 3 and 4. That's not true.
One and 2 are congruent, but I don't see how that would help us get to the triangle.
Correct. Yeah, good. You guys are proving my...
You could prove FGC and AGE congruent and then use that to prove 3 and 4 congruent.
So what you guys are telling me here is there's nothing else I can do on those triangles. There's no other sides or angles in ABC and ADC, those two triangles. There's nothing else. And you're correct. There is nothing else. So now we move on to another pair of triangles. All right. Again, I'm waiting. We'll get there. We need that third pair, but it's not going to happen right now in step 3. So you guys have been talking great. There is another pair of triangles in this diagram I can prove congruent, though. Name the pair of triangles I can prove congruent right now. Here we go. 7. Sinjin, what are the triangles I can prove congruent right now?
FGC and AGE.
Correct. Not in step 3, but I still need to say what? Anybody want to chime in here? I still need to say what about it because they're not congruent right now at this point. I can't write step 3, those two triangles are equal. What do I still need to tell you? I'm missing a key fact.
Angle 1 is congruent to angle 2 because vertical angles are congruent.
There we go. Angle 1 congruent to angle 2. Forgot to write my reflexive in there. Because vertical angles are congruent. Now you can tell me triangle FGC is congruent to triangle EGA. I'll just ask somebody. Method, why are those two congruent? 23, here we go. Luke, why are those two triangles congruent?
Side angle side.
Yep, good job, Luke. Side angle side. All right, there's a reason why we proved it. It wasn't because to make our proof longer. Why did we prove those two triangles congruent? That gets us what? Which helps us in the big triangles now. Anybody see any angles or sides that we can use from the side angle side triangles that we could also use in ABC and ADC? Here we go. Let's see. Anybody got it? Let's look at Luke, going back to you. 23, going back to you. Do you see any angles or sides I could use from those side angle side triangles, Luke?
Angles 3 and 4.
Darn right. I could go angle 3, congruent to angle 4, CPCTC. And do you guys see now that gives us a pair of angles in the big ones? So we are good to go now. Good to go. So step 6 is going to say now our triangles ABC is congruent to, if I go ABC, kids, I got to go CDA. Okay, 3 congruent to 4. I'm putting a lot of markings on here. I know. 1, 2, 3. All right, what's your method here? What's the method? Remember, we're looking at the two big ones. Why are the two big ones congruent now? By 13. Sophia, by what method?
Angle equal side.
Great job. Yes. Angle.
Also, When I
Angle.
first saw this, for some reason, the first thing I thought was diagonals bisect each other.
Oh,
but
don't say anything.
it's not a diagonal.
Don't say anything. Don't say anything. All right, you're giving away my fire here at the end. And then BC. I'm hoping people just didn't hear what she said. BC congruent to DA, CPCTC. All right. So it took us 7 steps to get there, but we got there. We got BC congruent to DA. Next up in the proof, show me ABCD is now a parallelogram. Show me ABCD is a parallelogram. Now, I'm going to say something incorrect again. Correct me. It already is a parallelogram because diagonals bisect each other. It's a parallelogram because diagonals are bisecting each other. Correct me. Why is that an incorrect statement for me to make? All right, let's hear from 24. Emily, going back to you. You're great at correcting my mistakes today. Why is diagonals bisect each other an incorrect statement?
Because you need both sides to be congruent.
What do you mean both sides?
Like A, B, and DC to be congruent, and then BC and AD to be congruent.
Hold on, though. What are diagonals, though, Emily? I think you're looking at the wrong things. What are diagonals?
They bisect each other.
Okay, name one diagonal in my diagram.
AC,
Name another one.
FE.
Ooh, whoa. FE is a diagonal? Does it attach to the vertices? No, right? So my problem, Emily, is how many diagonals do I have? Only one, so they can't bisect each other. All right, everybody see that? Everybody good? I can't say diagonals bisect each other if there's not 2 diagonals to bisect. There's only one. Hey, watch out for that on the quiz Friday. I'm giving you a heads up right now. You better watch out for that on the quiz Friday. All right? You may think diagonals are bisecting each other, but there might be only one in the diagram, like this one. We all good? All right? So I can't use diagonals bisect each other. I don't know. What am I going to do then? How do I make this into a parallelogram? Huh. And look at the work you already did. Look at the work, because there's a couple different ways we could approach this. How do I make this into a parallelogram now? There's a couple. Hey, remember, look at your last step. BC congruent to DA. BC congruent to DA. You already have one. Look at what you have already. I'll draw it out. You already have one pair of opposite sides that are congruent. I already have one pair of opposite sides congruent. So either get the other pair congruent or the same pair parallel. I'm going to ask you what you want to do, and we're doing it.
The other
Settle down. Maeve, going to you. What do you want to do, Maeve? Are you going to get the other set congruent or the same set parallel?
Congruent.
All right, how are you going to get, so you need to get BA congruent to CD. How?
CPCTC.
Done. Done. You just proved the triangle's congruent, so that also means, and I'll just put it in step 7 here, BA has to be congruent to CD by CPCTC. Good. Did anybody see how could I get the same set parallel? You have 3 and 4 that are equal, which are alternate interior, so they are parallel. Okay, so I could have went that way. But we are done with this show. ABCD is a parallelogram now. Opposite sides congruent imply parallelogram. Okay, good job, guys. Everyone all right? Watch out for that. Diagonals connect the vertices. All right, diagonals connect the vertices, and you need 2 of them to bisect each other. All right, let's end on this one. It looks pretty challenging, but you'll see this one goes pretty quick, I think. Okay, so ABCD, this whole bad boy is a parallelogram. And I'm also going to tell you that EF is congruent to FG. Prove to me that the figure inside is a parallelogram now. Okay. I'm sure this could be done multiple ways, but I just want it done a certain way so I can show you certain steps that need to be written down. All right, my first question to somebody is going to go to 20, which is Radhika. Here you go, Radhika. Now you can chime in. Are both diagonals drawn in A, B, C, D, Radhika? Are both diagonals drawn in?
They are.
They are. AC and DB, right?
Yeah,
So what are they doing to each other if that's a parallelogram?
they're bisecting each other.
Okay, so AC and DB bisect each other. And that's a parallelogram property. Parallelogram implies, sorry for the writing going quick, parallelogram implies diagonals bisect each other. Got it. All right, if they bisect each other, name me two pieces that are congruent in this diagram then. You can name me all of the pieces, but name me two line segments that must be congruent in this diagram if AC and DB bisect each other. Look at your diagram, name two segments that are congruent. 14, Ellie, going to you. Can you name me two segments in this diagram that are equal?
AF and FB.
Great job. AF is congruent to FC. AF congruent to FC. That should be congruent. Definition of a bisector. Everyone good so far? Now, could Ellie have said DF congruent to FB? Yeah, she could have. It would have been right. Definition of a bisector. All right. Can you guys now look at parallel? Yeah, not yet. Can you guys look at quadrilateral AECG now? What do you guys notice about it right now? What do you notice about that quadrilateral? What's happening inside it? Let's go to 10 here. Atticus, what's happening inside that quadrilateral? You got AF congruent to FC and you got EF congruent to FG. What's happening there? Here you go. Here you go. This is what here you got this happening inside right now. You got these two congruent and you got these two congruent. What's happening?
They're congruent.
What's AC called in that diagram? What's AC called?
A diagonal.
And what's EG called?
Diagonal.
So you got AC here and you got EG here. If these pieces are equal and the other two pieces are equal, what's happening to the diagonals?
They're bisecting.
They're bisecting each other. Everybody see that? So they are bisecting each other, which means this will be a parallelogram. But just like in your homework, you need to tell me they're bisecting each other before you tell me it's a parallelogram. So we need to write in EG and AC bisect each other. And you can just tell me why are they bisecting each other? Just show me the pieces that are equal. EF congruent to FG and AF congruent to FC. Got to tell me they bisect each other before now in our last step. Now you could say it's a parallelogram. AECG is a parallelogram. And then diagonals bisect each other implies a parallelogram. Okay. So I use diagonals bisect each other. I just want to make sure we had in the correct steps there. All right. Are we all good on tomorrow or into Friday? So no school tomorrow, quiz on Friday. I'll be available for help after school. Well, I shouldn't even say after school. I'll be available at 2:15 tomorrow for help. All right, bring questions, extra practice. This up on Classroom under Unit 6. Okay, guys? And the homework will be due, tonight's homework due Friday, 1 o'clock if there's no school tomorrow. All right, you guys have a great night. Let me know if you need anything. All right, have a great night.
So if we have a snow day tomorrow,
Yes.
should I take the quiz on Monday?
You tell me, Kyla, because I can. It's up to you.
Okay, because I don't know if I want to take it today. So I could probably also take it after school, like, or anytime tomorrow, if you want to get on then.
You let me know. I have periods 7 and 8 free, so okay. You just let me know, okay?
Okay.
All right, thank you.
Will there be like a?
1 second, Maeve. 1 second.
Oh.
Hello. This is John. I'm doing great. How are you? Yep. At school, yep. Okay. I just got to answer a question from one of my students because I teach. I'll be right with you. Okay, thank you. Go ahead, Maeve.
Will they be able to try, like, do you know, like, kind of like a 3D figure? That one question, number 5, like, will that be on the test?
No.
Okay.
Okay.
Thank you.
Yep. Take care.